Welcome back. So we've had a pretty eventful day so far. We've
into some things.
Yeah, we've shown how to get a map into our game. We've got our player on the screen now. We're moving them all around. It's pretty good. So I think to wrap up our first day here, we should get some collision in there and work on the status screen.
That'd be useful. Collision's good.
Okay, so let's dive right into adding collision. So in this module, we're going to basically be taking a look at adding collisions to our world. So we want to make sure that he doesn't, walk through trees or walk over top of other people, that kind of stuff. So, the normal stuff that you need for collision.
And we've already got the edge boundary, so that's one case.
So we keep him in the world. Now we just want to solve it when he's actually in the world. So we'll take a look at how we're going to add a collision layer. Then we'll take a look at actually detecting the collision. And then once we're done with the collision, we're going to take a look at our status screen, one of the most important parts of an RPG. We'll take a look at how to implement that, as well as displaying the current player stats on the screen.
That's right.
All right, so let's dive right in. We'll take a look at creating a collision layer first.
Sure. And so, again, this is the production code again, so I've just hidden all the little bits that we've already talked about, the maps and the stage from earlier. So we can just skip through to the most important bits and pieces that we need for this. Now, with the moving, the one thing we had talked about down here at the bottom was this little hit test part, and we said, ignore that for now. We'll come back to that.
It's magic.
It's magic for now. Don't worry about it, and we'll come back to that. So we're going to build up towards what this is doing and why we have it in there, and that'll be really completing our one check to see if the player can move in a given direction.
So we're going to do our bounds check for the world and our hit test all in one check.
Right. It's all going to be one check, and if there are nothing blocking the player in that direction, go ahead and move, and we're done.
Fairly simple.
So that's how it's going to work out. So what we got down here, we're going to need a couple of things, not only for collision, but also for interactions in the future as part of it. And this even goes for displaying our status screen, because we're going to also display our status screen when there is nobody in front of you, which we're going to need to check for if somebody's in front of us, and we could do collisions for that, or we could just do a look at what tile is there to see what's there in the foreground map. There's a bunch of different ways you could implement that sort of setup. So we're going to need functions that allow us to evaluate what square is in front of us, what square the player is facing, and other things like that. So we're going to have all of that stuff as well, but we actually don't need that for the collision parts in our example, the way we're going to do it. So we're going to come back to all of that later on when we deal with interacting with NPCs. That's when that will come in and really shine in its way. So I'm just going to zip down through all this code here.
So I guess the first thing we should talk about is actually what we're doing by adding a collision layer.
Right.
So it's kind of like how we did the maps and the foreground, right? We kind of want to add a collision layer. Now, we could do this in an array.
Yes, we could do that in another map array, similar to what we already did with the images. Maybe there are very specific trees that you want to have collision and ones that you don't want to have collision. So you could lay out another two-dimensional array and just block in, say a value of 1 means you can't go here and a value of 0 doesn't. And you could make it the same size as your whole level, fill all that data in, and then you would just check that information if you wish to stop the player from moving in any given direction.
So that'd be good if you wanted to if you were doing a map editor or something and you wanted to make sure that you had the ability for, say, an artist or something to add the collision layers on top. That might be one way to go. But we chose a different route in this one, correct?
Yeah, we're not going to use that, partly because Enchant already has a system that will help us out with that. So that's what we're going to do. And I'm just going to, I can't use Control F. Forgot about that. So I do have to go through and pull it out of the code here. Set stage, set maps, and here it is. So in this case, talking about the array way of doing it, we do have that implemented, but we didn't use an extra array of data that we filled in ourselves. But we are still going to use the same mentality to do it. What we're going to do is generate that array, so we don't have to type out a bunch of numbers again.
So we're using code to do this.
Yeah, so we're going to use code to do this. And the nice thing is you don't end up with a wall of numbers instead. So all we do is we set up a a properly named variable, so we're going to call it collision data again.
Makes sense.
Okay, and it's going to be an array of data, so we're just making an empty one-dimensional array of data in this case.
Okay.
Now, because we're also not really filling in a bunch of information at the moment, what we're going to do is we're going to, for every row that exists in our other map, we're going to push another array into that spot of this array.
So we're basically making a blank two-dimensional array. So we've got an array, and then we're going to add a bunch of blank arrays to that we can then populate with the data we need.
Right, that's exactly what we're going to do, and that will make our two-dimensional array. So you can think of it as putting in one row that's empty at the moment, and then we're going to put in a column, and then a column, and then a column, and then a column, and that gives you your two-dimensional grid. Okay. And we need to add one column for every piece of data in terms of our foreground's data length. So that's exactly what we're doing. We have our for loop here, and we're going to go through, and we're just going to populate the collision data by pushing in another blank array for every single instance of foreground data. And you mentioned
earlier that the push and pop is, push is putting it onto the stack, pop is popping it off the stack.
That's right. So we're just pushing all these on, and we're not going to do any popping in this case. We want the data to stay around, but we're building it up to be all of that data that we need. So then we have this next for loop, and again, it's accessing the foreground data, but this time it's talking about the first row's length. Whereas here, it's how many rows technically
in total
we have. So now it's how many columns we have in that row is what we're asking effectively. So as long as the for loop, we're going to start at 0, and as long as this j value is always less than that length, we'll keep doing these two lines of code over and over and over again. And then that for loop would end. We'd go back to this for loop. It would increment to the next row, push another empty array into there, and then we'd fill in that.
This is a good example of a nested for loop.
So this is a nested for loop, and it's a typical way to either traverse through a two-dimensional array and get data out, or to fill data in, or even to find one piece of data somewhere in your two-dimensional array by executing one for loop that trolls through the rows, and then one that goes through each column in that row. And that's what we call a nested for loop setup. We have two for loops. If you had a three-dimensional array, you could do three for loops, and so on, and build from there. And that's one way to either prune through the data, or look through the data, or insert data into a grid-like two-dimensional array structure. All right, so that's exactly what we're doing. And the collision data that we want to add basically into each one of those cells is going to be, again, just a simple collision or not.
Okay.
Okay, so 1 for collision, 0 for no collision. And the types of blocks we are looking for, so we're going to look in the foreground data at this row and this column, okay, where the I and j is controlled by our for loops. We're going to mod that value by 13. In other words, it's going to give us a value range from 0 to 12, okay, because we're going to divide by 13, so it'll give us either, it perfectly divides by 13, 0, or some remainder value otherwise. Now, what we do with that is we compare that to a value of 1. If it's 0, this if, which is, again, the question mark is a short form for that if, we set the true 1 value as a collision. So in other words, if it's anything other than a 0 or 1, it's going to block you.
Okay.
Up to 12. But then 13, if the number was 13 and you mod it by 13, it's 0 again. So that one also blocks. So
if you go back to our images, so that's basically showing us that we'll block, we won't block the water, we won't block the grass.
Actually, we will block them because they will come out as true in that case.
Oh, that's true, yes.
So we will block certain instances, and then certain other ones we won't. It depends on, again, the order of these and the way they're laid out, which ones we want to block or not.
Yeah.
In terms of whether we said true or false. However, it also depends on how we use the 1 and 0. Yes, we put true in, yes, we put false in, or 1 and 0, but that doesn't, you could change the equation to say, okay, well, actually what I meant was you should be able to swim in the water, you should be able to walk over the land, and then all of these other guys should block you.
Yeah.
Except for this mystical tree, which is
get to later.
Number 13, and this piece of water, which we want to let you swim through.
Yeah.
So you're right. It is flipped in the way that we're indicating collision versus non-collision. So 0 and 1 is going to be our water and our grass, and we are going to be able to walk over those.
Yeah.
So it's a valid place to walk is actually what we're saying by our true versus our false. So it's a valid place to walk, and then these are invalid places to walk. Each of these characters, if we ever define them, then this is 13. So because we modified by 13, it became 0 again. So that's not greater than 1. So that's a valid place to walk. This is a valid place to walk. And then this guy would not be again because he'd be 15, and 15 mod 13 gives you 2, and that's greater than 1.
Yeah.
Okay, so that's how the system is.
So some funky math going on there.
It is, and mostly it's just to allow us to do this sort of, you can swim under this half water, and we can do something cool with this tree that's identical to the one that actually blocks.
But if you were to add sprites to it or change this order, you'd have to work on that equation in order to keep it working.
Yeah, if you added too many sprites to this, you would eventually roll over 26, and that one would also not block.
Oh.
And so on. So you would have to be careful there. So I've done funky math, as you described it, with this image layout just because I want these two to not be collidable and these two to not be collidable.
Okay.
Yeah. So going back, so that's all that's setting into the collision variable, and then that variable gets put into our collision data two-dimensional array at that position, and then it just goes on, evaluates the next guy, figures out what mod of 13 of that value is.
It does that for every tile on the map.
Goes through every single tile in the foreground data.
Ah. So not our background data.
Not the background data, just the foreground data, and puts it all in there. So that's how that's going to work. And then the last thing we do is we take our collision data and map. The map objects actually support have an expected collision data as well. So we can put in the collision data into the map.
This is making me love enchant more and more every time we do this.
So, and that is all you have to do to set up collision data, actually.
That's actually really impressive.
Map. So you just have to give it 1s and 0s where you want it. So you could have written out the array by hand, okay, just like one of these, right? You could have done this effectively, but now instead of talking about grass versus water, you're talking about whatever kind of collisions you want versus you don't want. But that can be a pain to line it up with, where did I put a 3? Okay, which spot up here is a 3 that I put down here?
Yeah, that could become pretty tedious pretty quick.
It's very easy to miss. Human error in that case, data entry is very easy to mess up. So we're letting the computer, the program itself, do it for us by checking the values and putting in the appropriate value for us.
I don't know.
We assign it to our map collision data, and now that hit test function that we had down in our move, it will use that collision data
to do the hit
at
test.
this position to let us know whether or not you can walk there or not. And
so
again, that's built into the map.
So Enchant's handling all of our hit tests,
right,
and all of our cases like that.
Yes.
And you know, coming from experience, that takes a long time to do on your own.
It can be very complicated depending on the game and what procedures you have there and what kind of objects you have in there, but it's all handled for us.
Yeah, that's awesome.
Yeah.
Another really good point for Enchant.
Exactly. And so that's all we have to do. We set it up like that, so it returns the value of a hit test at the position where the player is, or the cell rather, the tile that the player is standing in. That's why we're using the straight X and Y values that we calculated here and not his actual position. Mm-hmm. Okay, we are using the calculated tile positions, and we're passing that in, and the map will tell us immediately yes or no, that's okay.
That's awesome.
And that's it. So we allow him to move, and he steps, and we're done collision.
Can you fire this up in the emulator just so we can see it in action?
Actually, I think it's actually still running, so I'll just stop that for a second. There we go. So now we have collision, and again, I have some other characters in here that we haven't talked about yet, and there you go. I'm trying clicking, but I can't. I can hold this, and he'll go all the way up, and then bang, and bang into that tree, and then we go over here, bang into that tree, and then, because I've played this game a lot, what about this tree?
Oh.
And then we got a little secret path. We can crawl around in here, and out we come.
Oh.
So the second tree that looks identical to the first tree, but because he is flagged as 13, he ends up being a not collidable spot. So I can walk into my secret tree path, okay, and nowhere else in the forest. And again, because of the half water, I can go down here and swim back if I don't want to take that tree path, right? I can't go down anymore because there's a solid water block, but there's only a half water block where I'm standing, so I can get in and out of the water, and it makes it look like I'm swimming. and I can walk through some of the water effectively that way.
I love that we're adding like secret, like almost Easter eggs to this game.
That's right.
Already.
And I mean, well, that's a big part of RPG games is exploration, finding those things. I mean, I can remember games where I spent hours just chucking bombs on every single rock everywhere in the freaking universe to find one entrance to a dungeon. Okay, and that was your old school RPGs, and that was allowed, that was okay.
Before the days of the internet walkthroughs.
Well, that's true too. I mean, yeah, you could gloat with your friends that you've actually, gotten to the 8th dungeon or whatever, or found the raft to the 4th dungeon, and so on and so on. And you can do all that. So that, we want to implement some of those old school features so that if you want to make a classic RPG like that again, you could. You'd probably want to randomly generate these secret paths so that they are there, but nobody can actually internet how to them.
Yes.
Because they move every single time.
Procedural driven.
It's a good way, and that's why a lot of people like procedural driven content nowadays, is so that we can avoid that. We can avoid that problem of people spoiling the fun.
And it gives us that fresh gameplay too.
It gives you a different gameplay every time you play. You know it's somewhere, but where is it? And you got to go and explore and find it.
Yeah.
Very cool. So we have all that, and that's our collision in a nutshell. We're good. Can
you show us how you put those special trees in there?
Sure, yeah. I'll just pop over to that. And again, it's right out of the level, the map data. Okay, so here we got 3 is our normal tree. And if you look in this block of 3 right there, there's our 13s. Okay, and then there's the ones coming down. And then to the left to get in and out. And again, 1 is all the clear area. 15 was the bad guy, and 4 is the cat, and 2 is our other guy. So I'm just coming along. There's these row of trees here of 3s. I enter the 13, go over 2, then I go up 3 more, and then I go over 2, and I've exited my little path.
So all we need to do is change the number 3 for the tree to 13, and it's now a secret tree.
Again, also why it's pretty much put at that position is so that it's very easy for us to look at the same data and know 3 and 13 are both trees, but 13 is the secret trees.
That's very cool.
So I mean,
it took like really nothing to get that up.
And you start to do data patterns like that. Like you want this still to be readable for us when we look at it. Mm-hmm. And I'm sure putting that sprite at that position was not an accident. We didn't make that sprite sheet, but putting it there is not just an accident. The artist didn't just I'm going to paint 2 trees that look exactly the same, right? It was designed ahead of time. It was developed ahead of time. We knew what was going into it. They put it together. They put it in that book, and then that's how it was going to be used effectively.
That's awesome.
So collision done.
Wow. I'm impressed. Because usually when you sit down and build a game, one of the hardest parts is getting the physics and collision.
5 hours later,
yeah.
I think it hit something.
So yeah, that's really cool. And I like the secret part too, adding that extra little layer, right?
Because it's already a gameplay feature and it really took no extra effort.
Yeah, that's amazing.
Very simple to add, and now you can do a lot with it.
Yeah, it goes to show how impressive Enchant.js really is.
Even the swimming.
Yeah, the swimming's pretty cool.
Again, by another, thinking of a way to use only a half of an image to give you a visual feature without really actually coding anything extra. We were already going to do the secret tree. Now we have swimming water. Same code, no real difference. I just changed one number in a map.
That's really cool. All right, so we got collisions in, right? We got that going. So our next step we were talking about was adding a status screen. Right.
Now this one's going to be a little bit bigger for the status screen. And let me just zip back up to our player here. Well, we had our set player function inside player. Okay, in the player class, here's the code for that. And again, we have all of his normal variables that control his animation and walking and his images and so on. And then we had this little block here where we specified his name, Steve, and his character class was Knight. Starts out with 0 experience. Probably could have been a little more verbose there. At level, starts at 1. Gold pieces, pretty
gold
common
points,
convention there, sure. 100. And an inventory. Doesn't have anything at the moment. These will bulk out later on when we get to a shopkeeper in the future. But these are your typical stats. Most RPGs have experience in leveling, and here we can see our level stats, so what you need, what changes in your character when you level up. Okay, so we've got our attack power, our maximum hit points there, our maximum mana power in case you want to, or magic power, whatever you want to call it, in case you want to put a spell system in your game, and then the experience you need basically to break this tier and go into the next level.
Okay,
That's
so
what
when
our
you hit
experience
10,
max is.
well, up to 10 is that level.
Is that level, and then
30 is that level.
So this is
50
the
that
value
level.
of whatever level you are. It checks that to see if you went up to your next level. And we're going to get experience from combat or what exploration or finding trinkets or magical
However
items
you want
or
to
whatever.
implement that, yeah.
So these we'll use later on, but it's still stats that we're going to want to show. So I've just shown where they are and where we're putting them in the player.
Well, I'm thinking you want to know what class you are.
Yep, so we
Right.
got the character class there.
You're going to want to know how much XP you have.
Mm-hmm.
You're going to want to know what level you're at.
Yep.
And you probably want to know how much money you have and what you're carrying around with you.
Those are all your progress indicators, right? So you want to see those things so you know where you stand sort of in the game. Hit points is great to know because you can go look for healing or whatever, or just not fight that thing and just run away, and that kind of stuff. So they're all important stats that you need even in the basic of basic RPGs. So that's why we've included them here. But the player still can't see them.
No, so we, need
we
to
have
implement.
them, the character has them, but we can't see them yet. So we need to implement a way to do that. What we've decided is that when you push that A button, okay, and you're not facing someone, that's your signal to the game. I'd like to see, my stats. So that brings back the whole point of we need to know which way the player is facing. So if I zip down again, let's just go over what it's going to look like when we print it out.
Yes.
So we need a display status function on the player, and this is what will be called when we find out, oh, he's not facing something, let's show him what he's got. The neat thing is we've made a little status label variable, and you can see that it highlighted a bunch up here that's already been used. It's a label, and again, label object is another one in the enchant universe for us to use. And it's basically, it allows you to specify a color of the text and a background color for the box, if you want to say like the area around the text. And then you can define a width. You could put in text right here and it would just show up right away, but we want it to be blank until the player pushes the button. So the player already has a status label, basically invisible, following them around, not displaying anything. And what we do when we want to display status is the function says, okay, I'm going to set the text in that label. And it's going to set it equal to this big string that we're concatenating a bunch of variables from the player with a bunch of words and some HTML tags. Because
some formatting.
Some formatting tags. BR is for break. Okay, so it basically puts a line break between whatever.
So everything will be on a
out.
new line as it prints out.
Right. So it'll say Steve the Knight, right? Because it's his name, the, and then character class. And then we add a line break. And then it shows hit points, the player's hit points. And then the out of his maximum hit points.
Oh, so it'll tell us what we
maximum hit
have
points.
and what our max is.
Right. And then mana, same thing, our current amount and our current maximum at our level from our level stats array. That's
so
how we're accessing
as we get more experience and as we level up, these variables are going to change.
Right.
So.
Because our display is already accessing our level stats array that has all the various tiers of these stats, which we just verify using the index of our level as the index.
Very cool.
And then player XP, player level, player gold pieces, and then we'll get into inventory later on. So basically, that's all the stuff we want to show. And we just do it by setting the text to that very long concatenated string.
Very cool.
So that's our display. Now, of course, at some point, he's going to want to get that off the screen so he can see what's going on again. So we immediately then write a clear status function. It makes sense. We got to get it in there. And all we have to do is set the text to nothing and set the height back to 0, and the message is gone. And again,
Very
hide
easy
inventory.
way to hide it.
Yeah, hide inventory will be for later. But that's all the minimum you have to do in enchant really to hide this kind of label. Just 0 height, no text, and now it doesn't draw anything at all. And it's just gone from your view.
So you were saying before that we need to check to see, are we facing anything? So why don't we walk through that code a little bit?
We want to basically have a function, first off, that's going to calculate what square we are in.
Okay, so what tile we're standing on?
What tile we're standing on. Well, we were tracking was the player's X position and the player's Y position, but that's not a tile, that's pixel.
Yes.
Okay, so we have to convert that to his tile coordinate effectively. So we just divide that by, again, the width of a tile, which is 16. Okay, and then we floor it. Now math.floor is a JavaScript built-in function. It's not part of Enchant. The math library basically is part of JavaScript. And floor just means drop it to the floor. Round it all the way down no matter what it is. It could
So
be
remove any remaining points.
pretty much. So it could be 1.9 and we would just round it down to 1. Okay, so any value of whatever this x is divided by 16, okay, will be rounded down to the integer, and that will be the tile we need for x. And then we do the same kind of idea for y, except we use the sprite height, which happens to be the same number, but this is in case you made a tile game where they weren't 16 by 16, it was 32 by 16 or something like that. This formula would still
still work no matter
more
what.
or less. And
it goes back to my point, don't hard code.
right, don't hard code. No hard coding. Bad, bad, bad. So facing square now is a function that also exists in the player, and it uses that square function we just talked about right here. So we need to know the player square, so we just say player.square, it calls this function, it figures it out for us, and now we have that square value. And we also need to know the square we are facing. So we don't know what that is going to be yet, but we make the variable so we can fill it in.
Because we don't know if we're looking up, down, right, left.
Right, so we have to do that. We can do that with a series of if-else statements or if statements. So if our player's direction is 0, okay, and this is exactly 0, that's what triple equals means in JavaScript, then we will set the facing square to the same value as the player's current x, because he's 0, he's facing towards us. So he's looking down. So that means we have to go 1 in the y direction, because down, again, is positive in y. So that is the square he's facing. And then if his direction is a current value of 1, then he's now pointing upwards, and that would be a negative 1 step in y. So that's the square he's facing. And then 2 and 3 are left and right, so we add x or we minus x, depending. Add is, of course, facing right, and subtract is facing left. So now we have the x and y tile value for the square we are facing. Now, of course, there's one gotcha. If I'm at the edge of the map, like the far left, and I turn and face the left, I'm looking into the void. We don't want to access an array at -1, 3,
No,
because
get an exception.
that's not going to exist, right? 0 is the minimum it's going to be in that direction or whatever, and vice versa. So we now have to verify that if the facing square's x value is less than 0, or the facing square's x value is greater than the map width divided by 16, or the facing square is less than 0, or the facing square is greater than the map height divided by 16, we know you're looking in one of the 4 directions at the edge of the screen and looking into the void. So we are just going to return null instead, so that we know he's not actually facing a square at all. He's facing
Out
oblivion.
Oblivion, yes.
So otherwise, we just return
The facing
the square we calculated because it's valid. So this is just our valid check of whether or not we're facing a proper square. So the player's facing function uses that function to get the facing square, and then all we're going to do is, well, if it's not, if it's basically invalid, return null still. But if it's not invalid, then we go ahead and grab the data from the array at that facing square x and y position, and that's what we return. So we get the tile value from the foreground data array at that position.
So those 3 functions work in unison to basically tell us what tile we're looking at, and the 2 tiles around us, basically.
One does the tile we're on, and then, they work in unison using that one to look at, I'm looking in this direction, and this is the tile or the void, and then we can use that to verify what, the third one verifies that it is a tile, and here is the type.
Yeah, and returns what's there, right? So
right, turns the type, so it'll be the value from 0 to 15 or however long your sprite sheet is of the one that's there. Now, what you want to do when you find out that's what's there, that's up to you. In our case, we want to basically find nothing. We don't want you to be facing one of the other characters that I've already thrown into the game.
So if we're returning -1 or
sure,
0.
negative one was in the foreground map. I'll just pop back over to it here so you can see. Foreground map, -1 is, there's nothing there. Also, if we're facing a tree, We didn't give any interaction with trees at the moment. You can't break branches off it. You can't climb the tree. So we could probably accept that as well, right? Yeah, but if we were facing a character or something else, then we probably want to actually mean to interact with the player. That's why we're facing them, right? So we would trigger something different. So
I think we're going to be looking at that later on as well.
Right, we're going to do that later on. So we'll accept pretty much anything right now as good enough.
As being valid, yes.
Yeah. So if I go back to the game, so that's all of our facing functions. And now, where is that triggered? Well, we said that was going to happen on a press, right? And we already, or on whatever button press we wanted. And we already saw how we could bind the keyboard key, so spacebar works for it, as well as we have our button that is set up to do that. Down.
That's in our set map, or set stage.
Oops, set battle, too far. So we have our button as well, and the button, there we go. Where are you?
Almost there. There you go.
Set stage. There we go. And our button for the A, so we have our on touch start, so when we touch the graphic of A, it will go ahead and, there it is, calling player facing, which then triggers what direction we're facing and triggers what square we're triggering and all that. It gets us that value, and if it's null, fine, show the status. He's not facing anybody important. Or if the sprite's role, so again, sprite is just a character, so something that's in the foreground. If its role for that type is null, then we go ahead and, again, show the status. So what is this sprite roles? We'll get to that. Effectively, it's just going to be things like shopkeeper or bad guy or talkative friend. It's basically an array that, again, matches up with our sprite array images. So grass, not going to have a role, so we just leave it blank. And water, not going to have a role, we leave it blank. Then we get to a tree. You could, interact with the tree maybe, so you could say climbable, and that would be its role. Climbable is not nothing, so it wouldn't show us the status. Instead, it would go down into the else and do the action of whatever that role was. So if it was climbable, he could climb up the tree and do his thing and then climb back down, and you could talk about that, or maybe finds nuts once in a while or gets attacked by a squirrel. So that is what we're going to get into when we get to NPC interactions, and that this is going to be the same system we're going to use, all this code that we just did to make sure we're facing nothing to show the status, we're then going to use to actually interact with other things later on.
Makes sense.
So we know we're facing nothing, so we go ahead and we display our status, which is that function we looked at that just prints out everything that we wanted.
Very cool.
Let's just see what that looks like, just so we get the picture of it. So here I am standing around. Okay, I'm already not facing anything. So if I just push A.
Oh, wow.
There's our little text box, Steve the Knight. Okay, 10 of 10 hit points at the moment. I have no magic power. I'm inept. I'm a knight, I guess. Fine. I have no experience. I got first level, 100 gold, and nothing in my inventory. And what we've done, one thing that we have to do still is, well, how do we clear this off the screen?
Well, yeah, because you don't want to be playing the game with this the whole time.
Yeah, and of course, pushing A is the thing that makes it show up because I'm not facing anybody. So what I've done actually in the code is, if you push any direction to walk, okay, it goes away.
Oh,
so if I go up,
smart.
Yeah, so that's how we've done it, and I'll show you that last little bit. And of course, that's in our move function for the player, and we skipped over it there. There it is there. So if we push up, just clear the status. If we push right, clear the status. If we push left, clear the status. If we push down, clear the status.
Very cool.
And that's it. So that's our complete system to view our current status of our player whenever we want on the fly. And if we want it to go away, we just walk away effectively, and it's gone.
And we've set this up in a way that we can reuse it for other aspects of the game as well, right? So
and that comes down to design and understanding where you're going to take that game, right? You see the tie-ins, and we're doing the simplest, easiest parts that we can do right now that eventually lead to other steps that build upon what we are going to build. And that's how you want to approach every project. You go ahead, lay out every feature you want, get a wish list of features in that, break it down into which ones are really just disguises of others, like the secret tree path and the swimming in the water. People would put them down as two things, but you can realize, oh, actually I can do that in the same way. So that would become just one task. And then you break it down into which tasks need to be done first, displaying the map makes sense, getting all that level laid out, getting the foreground data, get a player that can move, okay, and you just build up as you go, and layer on the different functions. And the reason why this is good is because it allows you to test every step of the way. When you complete one full feature, you can go ahead and bug test it. You can get some other people that have outside opinions of it to test it, make sure it functions right or as they expected. Because if you're testing your own code, you know how it works, so you'll verify that it does, but then you won't try anything else. A lot of people will just be like, yes, it works. I'm so successful, moving on, right? They don't try edge cases, we call them. They don't beat around the bush, as it's called. But if you give it to somebody else and don't tell them what they're doing, just could you play around with the movement, make sure it feels good? Right? I'm not asking them to look for bugs. I'm not asking them to try to break it, but they will be like, oh, I can move? What buttons? Well, I guess I push this gamepad thing, and they start clicking on the buttons and trying things out, and they might click a button that you forgot to bind, and then it errors. They might run off the map, and then it crashes because you didn't put the side borders in. They will find things that you didn't test because you, in your mind, coded it to work a specific way, and you only try that way. So it's a good practice to get into, to layer all these features in, and at each stage, get someone else or just another coder or somebody with fresh eyes that is apart from the system to try it out for you.
Well, it's really important to test, right? Like at the end of the day, testing is one of the most important parts of game design. And I like what you're saying there. And going out and finding like your target audience and having your target audience test the game is a good way to get the feedback for, maybe you want to reiterate and change the mechanics of the fighting or whatever it might be. They're going to give you the feedback, and since they're your target audience, they're the best ones to be asking for that feedback.
That's right. And at the same token, I mean, I'm usually looking for, is it written right? Is it functioning properly? Are there any things I missed? But at the same time, you can watch them and evaluate, do they pick it up naturally? Right? In the current game that I'm working on, that was a big thing, that it's a pinball RPG mashup. It's got to naturally play like pinball or feel like pinball, but it's got to be naturally feel like an RPG and play like an RPG. If you want to do something, do you know how? But at the same time, we have two target audiences. So now you got ones that know how to do this well and one know that how to do this well. Do they get each other's crossovers where they're not used to playing those kinds of games? And that's the kind of stuff that you can watch for too as you're adding in mechanics, because you're always going to have to iterate on any main mechanic more than once usually to make sure that it's functioning well, that it runs smoothly, and that people naturally get it. If there's less barrier to entry, you're going to have a wider audience, you're going to do better.
What's the difference with somebody putting down the controller or putting down the device and saying, I'm not going to play this, I don't understand it, as opposed to like if you're watching them and you can implement stuff, and maybe it's put an extra tutorial in, maybe it's explain that button a little bit more, right? And just the little things that go a long way at the end of the day for selling or getting you downloads for your game, right?
Yep, and even disabling tutorials, because some people don't like tutorials. They don't want the game broken up in that way and having to read and do all those things.
I'm a strong believer in having a checkbox of no tutorials, please.
If you've designed your game well enough, you actually shouldn't really need tutorials, because you should be leading a person into each experience, and then you should be later on reintroducing it to make sure that they've learned it originally. And certain games did this really well, and there's documentaries on it and things like that, where if a person reads something and they're in the middle of a game, they're concentrating on the game, they're looking at what they're playing, they just gloss over and be like, hey, okay, that's what I'm supposed to hit, A. Yeah. But it doesn't sink in, it doesn't gel, and it doesn't sit there. So if they come up against a pit and they have to figure out, hey, how do I get over this? And they experiment, there's only two buttons, A and B or whatever, and they hit A and it jumps over, they're going to be like, wow, I learned how to, they're not even going to think about it, they're just going to be like, A jumps. And they know now because they didn't read to understand it, they experienced it, and it's ingrained and it's already getting into their system. And then you reiterate that later and make sure that they have picked it up.
The tutorial levels, right? We've seen a lot of games doing that more recently, where it's not a whole bunch of heavy text. It's just by the necessity of having to do the action, you learn the action.
I never played Mario and had, push A to jump over pit, hold B to go, hold B and touch a turtle shell to pick it up.
Yeah.
But we all figured out how to do it at early ages just by experimenting and just going through, because
it was intuitive.
It was intuitive, and there weren't that many options, yet there's still a depth of range to mechanics. Mario 3 had major mechanics and so on, and you didn't need the tutorial still because they designed everything and led you into it one after another and then retested you knew how to do it and sort of brought you into that atmosphere.
Yeah. That's actually some really, really good advice, right, for the developers out there that are thinking about, like, what's the next step after I've built my game and before I take it to production or release it to the store, what are the steps that I need to take? And that's a big one, right? Getting people to test it and getting it into the hands of people that you wouldn't necessarily maybe expect to play your game, because it's a good idea to test the waters in every genre that you can, right? And see who might be enjoying it and the downfalls that they kind of show you.
That's right.
That's really good. Well, you know what? I think that's a good point to end the day. I think, we've seen a lot. We've walked through, how to add the maps. We've got this, well, first we started off with setting everything up. We got Cordova up and running inside with our templates. We got Enchant. We showed how to import all that. We showed off, how to build the 2D array map styles.
Yep, that's right.
Right, how to bind them to images. Then we added a player. We gave the player a sprite and that, and a little bit of animation. We had him moving around. He's got collision on him now, and now he's even got stats.
So you're on your way to,
That's a pretty good chunk of game design, put together there. And
that's right. And then next week we'll be back, and we're going to do some more as well. We'll expand upon that.
So should we give them a little hint on what we're thinking about doing?
I guess we could. Well, then they'll do it themselves.
So what we're planning on doing in the following week is we want to expand this a little bit more, and we were talking about NPC interactions. So what we're going to do is we're going to show you how to interact with NPCs inside the world, give them different roles.
That's right.
So we're going to show you how to just have the chatty Cathy sort of NPC that just talks to you. We're going to show you how to set up a store. So you can walk up to the NPC and talk to them and get some items from them. As well as we're going to actually show you how to build a battle system.
That's right, yeah, get a battle system.
That bad guy in the turned cap there, we're going to end up battling him at some point. So definitely worth coming back and checking out, and we're going to expand the game quite dramatically.
Now don't forget to do the poll.
Yes, please do the poll at the end of this video. It's the best way to give us feedback and let us know what you liked and what you didn't like.
Or if you want to see more of these and extend and keep growing it.
Exactly, right? It gives us the ability to really target what you guys want to see. So please, by all means, fill that out. And yeah, thank you very much for tuning in, and we'll see you again in a week.